Okay, so let's get started. All right, so do I have everybody's attention? Okay, so we have some extra chemicals here that weren't listed in your initial lab. So some of them might work really well, and some of them might not work so well. You can actually buy flame test kits, and when you buy a flame test kit, it will have chemicals that are pretty much guaranteed to do what you want them to do. These might not do what we want them to do so much, all of them, but I know some of them will. So it should. This is fun. So we talked earlier in the other class, in the junior class, about how fireworks, right? Fireworks are colored. Fireworks are colored because they use specific chemicals to produce particular colors. So what I've done is I have taken our chemicals and I've put them in nice little containers, and you'll see why in a minute, but I wanted to show you the original containers too. So our control is going to be the same liquid alcohol that we use in our alcohol burner. We're going to use a Bunsen because it burns much hotter, but this is an alcohol burner, which you could use if you didn't have a Bunsen, right? And then this is methanol, all right? This is going to be our control because we're actually going to dip every one of these chemicals in the methanol because it's going to be our flammable medium, all right? So I'm going to move this over here. All righty. And this has methanol in it, this little container here, all right? Next thing we're going to use is lithium sulfate. Anybody know anything about lithium sulfate?
No.
It comes in a little bottle. Anybody want to try and guess what color it might produce?
Blue.
Maybe blue.
Probably a clear white.
Clear whitish color. Okay. So this is our lithium sulfate.
Red.
And red, she says. All right.
I said green.
Green.
Green. It'll produce a halo.
Now this here is potassium chloride. All right. Potassium chloride is a salt. And sometimes this is like a salt substitute. Is that there? All right. Now next we have our old friend here. Potassium nitrate. When did we use this one? This separating mixtures lab, right?
Yeah.
Where we use the vacuum filtration and the fractional crystallization. We use potassium nitrate. Potassium nitrate, this is not the original container. They were not so sturdy. So potassium nitrate comes, you can get this at Lowe's. It's a stump remover, saltpeter, okay? Next I've got, what was that? Oh yes, barium chloride dihydrate, barium chloride. All right, it's another salt, barium chloride. Anybody know what they use barium for? They use it if you are having a medical procedure done that involves needing a dye in your body that's radio opaque. So like say you swallow something and they want to see your digestive tract on an x-ray, or they want to see your veins or arteries on an x-ray. They very often use barium for that. They make a barium shake that's sort of pink and strawberry flavored, not great, that you can drink, and then they can x-ray your insides, right? Pretty cool. All right, sodium borate. Everybody knows this one. What do you use it to make?
Slime.
Slime. What else do you use it for?
Oobleck.
No, that's cornstarch. But you do use this for cleaning. It's cleaning agent. It's on the back. Look, it's got laundry, carpets and rugs, right? But yes, slime. Everybody knows it from slime. All righty. Here we've got strontium chloride. Don't use this for much. This one's fun. This one was my first chemistry professor in college's favorite element. You'll see why when we get to it. It's pretty fun. All right, now we've got calcium chloride. Calcium chloride is actually used for, it's a cleaning agent too. And you can actually find it when people that do home brewing, like Jason does home brewing, he makes beer and cider. People that do homemade cider and wine, it's like a bleach that's super, super mild that you can run through all of your equipment to make sure there's no bacteria or anything growing in your piping, tubing, whatever. All right, cupric sulfide, Cu, cupric. We're going with a Latin root. This is copper. And you can see this is the only one that isn't white. All right. Anybody want to guess?
Hello.
Bluish. This one and the lithium are my favorite. All right, now we have magnesium chloride. And I also have, I'll skip one. I have magnesium sulfate. That would be Epsom salts, right? And then I have lastly, sodium chloride, which is what?
Table salt.
Table salt, okay. Sodium, where do you see sodium aside from food, you know? Water,
Drink.
drinks, okay. This one, you actually do see the light from this pretty often. We'll see when we get to it if it reminds you of anything, but that's a pretty common one. So we're gonna start, I'm gonna show you all our control. So anybody remember what the control was?
Control, delete.
It's methanol, right? Straight up methanol. Now I wanna tell you that what we've got going on here is, actually I need a little more in there. What we've got going on here is a couple different beakers. These are, it's gonna be fun. I'm gonna fog up my glasses so much. I might have to pull my mask off just so I can see what I'm doing, but y'all are way over there, so. These are all soaking in methanol. These are just regular swabs. This is water. So when I'm done with them, that's where they're going. Yeah, I'm gonna have to, sorry guys, I can't see. So let me like not cause a fire because I can't see. There we go. All right, y'all are way over there. Are you okay with this? Okay, because everybody's sitting back from me. All right, that's better. I can actually see now. All right, so this is our methanol. And what we're gonna do here is each of these little containers has a little bit of the chemical in them. I'm gonna show them all to you. We're gonna test each one. And then we are going to configure a rainbow. And we're going to use a wick that's been soaking in the methanol, connect them all, and light a whole big rainbow.
You tried putting on the one of the caps for the lid.
That's why it didn't work. That's why I grabbed the wrong thing. See, I couldn't see. Now I can see. All right, so here's our methanol. And these have been soaking in the methanol, right? So this is the same thing. It's just a clear liquid. I just wanted y'all to see that it was a clear liquid. And I'm gonna put the lid back on it. And I'm gonna light up our Bunsen. Okay. So that we have it going. All right, there we are. So watch and tell me what color we get.
White. So air.
Does it look blue to anybody else, or is that just me?
Black.
It looks kind of clear, but a little blue. Now that orange is the wood. See, the wood is now caught. So you want to test it one more time? Okay.
Air.
It's pretty clear, but for me, I think it's a little blue.
That's blue. Oh yeah.
Yeah,
that's blue.
See it?
Yeah, I see it.
Okay, good. We're gonna stick it there. Yeah, all right. Now, the next on our list here is our lithium sulfate. Now, I want to show you guys that the lithium sulfate is crystals. Do you see it? All right, so what we're gonna do is I'm gonna take this guy that was soaked in the methanol, which we know is our what? Control. And I'm gonna grab some of these little crystals on here. Some of these are big, so they're hard to grab. All right, are you watching?
Whoa.
Red. Dragons.
You get like a red, kind of a pinkish red. See that one?
Green near the bottom.
It's sorry.
That's really.
That was cool, right? All right, so now I'm gonna leave it open, but I'm gonna put the lid right behind it. All right, potassium chloride. Okay, this one just looks like regular salt. All right, I'm gonna dip it.
Go with yellow.
What do we think?
Green.
Yellow, green, something. All right, you watching?
Green.
Normal.
Well, look, it's pretty much orange, but I see a little purple at the base. Do you see it? Now let's try that one more time because that one went ahead and I see a little purple at the base.
Yeah.
You see a little purple at the base? Just a little.
Yeah.
Okay. All right, so there is potassium chloride. All right, how about potassium nitrate?
Oh, that's we use that.
Yeah, you did for the fractional crystallization lab. This one just looks like a salt
We
too.
use that for one thing to make smoke.
When we tried to what?
Make the smoke.
Yeah, we did.
Green.
Yeah.
Green. Whoa, it's pink.
It's like pink purple.
You see lavender, lilac color in there? That's what we're going for. That's what it should do. Did everybody see it?
Yeah.
You want to see it one more time?
Yes.
Okay, this one has like the purpley thing going, like a lavender, lilac color. Okay,
Yeah, there's the little.
there it goes. That's cool, yeah? All right, now,
So far, my favorite is
Berry.
the red one.
I'm gonna keep
Yeah.
doing green until I get it.
barium
Copper's
chloride.
gonna be green.
All right, this is a salt, but it's kind of a wet salt. Kind of sticky and wet. Ozzy, you're fine. All right, let's see what we got.
Green. Oh,
That one's pretty bright orange. Now, this is supposed to be green. And I'm
I saw a
looking,
little bit of green at the
and I
beginning.
do see, you're right, Drew, I do see some little flecks of green. Not a lot, but a little bit. Okay, this is one of the ones where when I tried it, I was like, All right, sodium borate. Okay. So this is your borax, remember?
funnest name ever.
Whoa. It's like small scale fireworks.
This is another one that's supposed to be green. I see a tiny bit in there like before,
Nope.
but not much.
I
It's
see
supposed to be,
nothing.
they say, apple green. Though I'm not convinced that's apple green at all.
This is.
All right, strontium chloride. This one is for my man Bonsi Kalra, my first chemistry teacher in college. This was his favorite.
Red.
Ready?
SpongeBob color.
Wow. Oh my gosh.
Now you see why it's his favorite?
Isn't that the guy who like threw it on?
He threw it all over the room. Yeah, woo, I got warm. Heat came up. There we go. That was pretty, yes? Yeah, it's all right.
Big of a deal.
That's why I have four
It's
sets.
still on.
It's okay. That's why I have four sets. I just turn it around.
What else is it gonna
Yeah,
burn?
yeah,
It's not even hot enough to burn the.
Think.
Glass.
Good call. No, this is
Yeah,
rubber silicate glass, so it's not gonna crack. All right,
And it's really heat resistant.
calcium chloride.
I hope the
Now this
flat-
one's hard to pick up because it looks like little beads. See it? All right, let's see. Can we get a little bead on here? It's very hard to do. Okay, I got a little one.
Clear.
Purple. I saw red.
Red flash. It's supposed to be orange flashes.
I saw.
This one is
red.
supposed to be kind of yellow, but it's very hard to, maybe this one will go
I
better.
see a little bit of red.
Yeah, I saw a little red too.
Really red.
Yeah, it's probably coming off of the burner. I think Michael has a point. If I look right there, I see an itty bit, there we go. There's a little strontium chloride on the side of the burner, which was giving us, see it? It was giving us a little bit of red. Okay, here is, we'll save that one for last. All right, magnesium chloride. All right, this one looks like little crystals, like bigger chunks. So it's kind of hard to pick up too, but we'll give it a shot. Now, this is almost like a test because this one is not supposed to produce a color. So I didn't see much. Did you see much? Neat.
I saw a little orange.
A little bit. This is magnesium sulfate. So this is bath salts, right? Real bath salts. This is Epsom salts.
They're not gonna do much.
No, not at all. Nothing. Do you see that?
I see a
Almost
purple.
nothing. That was pretty cool.
I
Try that one more
a little
time.
bit of like a purple and orange, but
Yep,
it was just a
almost nothing. Look,
lightest section.
look at that.
Guys, whoa! I saw a little bit of red.
Almost nothing at all, which is what we want from that. All right, this one is sodium chloride. This is table salt, okay? And if you've ever been in a parking lot at night, those amber lights, that's sodium, okay? So if you've ever seen parking lot lights at night, those orange ones, that's what you're seeing is sodium lights. And lastly, my favorite, cupric sulfate. This is our
I
copper.
said be green.
It's gonna be yellow.
I want to see
Copper's
green.
green.
But if when we burn the copper
Look,
wire,
yeah!
it's green.
Yep.
Cool.
It's like red and green.
Pretty, right?
I finally got to see green.
All right, so now what we're gonna do
My favorite is the red one and the green one.
is turn the sky off for a minute and look back here at, we have some charts, okay? And we're gonna make some arrangements here. So first things first, get that out. Our methanol. What color was our methanol? Who remembers our control? Mine, he can go somewhere. Anybody remember what it was? The first one, orange. The control,
Red. Water.
it was blue, right? It was the same color as the, pretty much the same color as the flame it was burning in, right? So get up under there, booger. It's gonna fight with me. All right, so our methanol was blue, right? The calcium chloride was the one that was supposed to go, remember what we were looking for? We didn't quite get it.
Yellow.
We were looking for yellow, okay? We didn't quite get it. We were hoping for it. And what did we get from the sodium chloride?
Red.
Red. Y'all remember? It's kind of amber colored, kind of orangey yellow. Do you remember? That one burned nicely, right? All right, our potassiums, our 2 potassiums. We had potassium chloride, right? All right, and potassium chloride, we got,
Red.
it was the blue one with the purple in it, a little bit of purple in it. Remember? And then our potassium nitrate, it did even better with the purple, right? It did really nice purple. It went like purple, like a lilac color. And then lastly, we had the magnesium sulfate, and it did what? Do you remember? It did nothing, right?
Yeah.
Nothing. All right, so we also had sodium borate. And it was supposed to go green, but it really didn't. It was a bummer. It happens. All right. Then this one, how do I take one out without taking them all out? Let's see, am I any good at this? I am probably not. Yep. Let's put him here. Potassium nitrate. And then we had barium chloride. Do you remember what color that was supposed to go?
Red.
This one was supposed to go green. They said apple green was the color you're looking for. But we didn't really get a good apple green, did we? And then we had, yeah, no, that would have been cool. I would have loved it. We got potassium chloride, and on the other side we had strontium. Now, what color did the strontium go? Anybody remember?
Red.
It was the one that was super bright,
Dang, it was
super
dark.
bright red, right? Remember I said that was my chemistry teacher's favorite? Yeah, it was pretty cool. All right, now we got sodium chloride. Come out without letting everybody know. Come on, play nice. There we go. All right, my favorite. What did we get?
It was the green.
Cupric sulfate was the green, but it was a green with kind of a little blue green, right?
Yeah, I remember because we burned the copper wire in that one.
That same thing. Very good. The copper wire did the same thing. All right, and then lastly we had the lithium sulfate. And what color was that one? Do you remember?
It was red.
Yeah, it was like the hot pink red, right? It was not as red. The strontium was like a red, and this was like a pink red. All right, so now what we want to do is, just because we can, really for no other reason than because we can. All right, so here's what's happening. Here's what's happening. We were talking about how electrons, I knew they were going to do that. Look at that, they all fell. It's because I'm live streaming, that's why. If I wasn't live streaming, this one is stuck. Oh my. Got it. So we talked about how, hang on you guys. We talked about how electrons live at different energy levels, right? And we talked about how the Bohr model is not a really good model to describe where an electron is at any given time because they move like waves and particles, right? But for the sake of understanding what's going on, I'm gonna kind of sketch one. So say you have a nucleus, okay? And you got your positive protons in here, and then you've also got what? Neutrons in here, right? Okay. I don't know how many we have. We'll just pretend we have 2. All right, and then you've got what they sometimes call shells or energy levels, right?
It's a coconut.
Yeah, coconut. So in truth, this guy is going to be itty bitty, right? Do you remember we said the other day that if your nucleus was the size of a marble, your entire atom would be the size of like a football stadium, right? Lots of space, lots of space. All right, so if you have electrons here, let's say you have one here, okay? He's happy here, all right? Because he's at his lowest level that he can be. And let's say you've got one here, but he could be here. He's excited, that's what they say. Okay, he's very excited. And he wants to go back to his ground state at all times. So what an electron does to go from one level, a lower level, to a higher level. It goes this direction to a higher level, and what happens with its energy? It's going to have higher energy up here. So what has to happen to it between here and here? If it's going to have more energy here, what has to happen as it moves?
Build up energy.
Yeah, say it louder.
Build up energy.
Yeah, it's going to absorb energy. Okay, so it's going to absorb energy. Okay, that's going to happen when you get it hot with fire. Okay, it's going to jump. And then what's going to happen as soon as it settles or cools off, which is happening rapidly with all those little atoms, you can't see which ones are hot, excited and calming down, is it's going to come back down. And when it comes back down to a lower energy level, if it absorbed on the way up, what's going to happen on the way down? It's going to release it. Okay, and when it releases, it's going to release energy, and we're seeing energy in the form of what? Light. We're seeing it in the form of light. Now, you have your electromagnetic spectrum here, right? Okay. All right. Now, it would be great if we could say, oh, there's a perfect correlation between, a red color being shown and it being like a low frequency. It is a low frequency wavelength, and a low frequency and a long wavelength if it's down here, because that's how we see visible light, right? Down here you have infrared, up here you have ultraviolet, and the lower frequency is down here, the higher frequency is up here, and there's high frequency that we can't even see, right? That's our ultraviolet, like that's how you get sunburn. They're really, really high frequency. They have a lot of energy. They're bad for your skin. For me, super pale people, they're really bad, and you can't see them, right? So what we're actually seeing is a combination of colors. We're not seeing one particular wavelength. Our eyes are perceiving a mixture of wavelengths. So it's not like if you see blue, you go, oh, the energy released by that electron moving down produces exactly this type of energy on the spectrum. It doesn't line up quite like that. It's a mixture. So if we had a good chromatography machine, we could see that every one of these atoms is producing, every element is going to produce a very specific spectrum, but they show up like individual lines on a big, you ever seen like those UPC codes that are, where's one? You know what I'm talking, these things. See this? It would look like this, but only certain lines would be colored, and they would go in the direction of the spectrum, right? So that's one way to identify a particular element. So if you have a cool chromatography machine, they do all those calculations inside, and you can take like a little tiny syringe and literally squirt an itty bit inside the machine, and it'll tell you exactly what's inside your mixture or your solution or whatever it is you have, which is pretty cool. So now what we're gonna do is, with all the different salts, we had a lot of like such and such chloride and such sulfate or whatever. But these were the elements we were really focusing on. This is what we were really looking at. Strontium, lithium, sodium, calcium, barium, boron, copper, methanol, and potassium. All right, so methanol is not the element, right? It's not an element. This is our control. So these are the colors we should expect to see if we line them all up and light them all up at one time. So we should expect to see a rainbow, but some of these in the middle we know we had some issue with, right? They weren't quite doing what we wanted them to do. Yeah, they weren't quite participating in the game. But that's all right, it happens. So what we're gonna do now, and this is where it gets fun. I'm gonna scooch some of these extra salt. I'm gonna get it in my eyes, out of the way. All right. What goes first? You tell me. Strontium chloride. We're gonna put it right here, okay? There's the cat. What goes next?
Lithium.
Lithium, where's my lithium? I'm gonna put it right next to it, okay? And, wait a minute, grab the wrong lid. Sodium, where'd my sodium go? Sodium, 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 where is it? Oh, some of these are upside down. There it is, right here. I'm looking at it. All right. Now what?
Calcium.
Calcium. Okay. Now what?
Barium.
Barium, 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 barium. Okay. Boron. Where did the boron go? Hello, boron. Where'd it go? Wait. I just saw it. No, I didn't either. Potassium chloride, potassium nitrate, strontium, magnesium, cupric. Oh, wait. I put sodium borate when I should have put sodium chloride. Come back to that one. All right, what's next?
Copper.
Copper. Cupric sulfate. Okay, now what?
Methanol.
Methanol. This is our plain, boring methanol, right? Nothing in it. Which potassium? Both potassiums. So let's stick both potassiums there. Potassium nitrate and potassium chloride. They were both kind of eh. All right, now what? What up? That is not strontium. What is it? What's next?
You can't see, you're in the way.
You can't see.
Copper.
Copper. Cupric sulfate is over here. We already did that one. Where are we next? Methanol, potassium. We got them all. Okay, sorry. Where did the strontium? That's oh. Oh, so wait a minute. What happened here? We've got something confused. Da-da-da. Oh, I didn't do that on purpose, did I? So now how do we find out which one is which? Is this really sodium and is this really strontium?
The fire thing. We use a new cool app on our phone that helps us identify stuff.
It will analyze this salt.
But the magnesium's on the end, right? Because they don't do much. So how do we know which was which?
You should have labeled them.
I did, but see, I left the caps off. Da-da-da-da.
Rewind the video.
Rewind the video. Nope, we're gonna do it the right way.
Do it again.
Yeah.
Oh, you're-
Okay, let's see. Isn't that cool how that works? So this one's labeled sodium. Is it really sodium? Looks like sodium to me,
Wait,
right?
Is lighter? Is gasoline really gasoline? We need to test.
And this one's labeled strontium. Is it really strontium? No, that's not strontium. What was that?
All these are real Aussies.
Which one was purple?
Oh, it was the lithium.
No, it was the potassium.
Well, lithium's like
Potassium nitrate. So wait a minute. The strontium was what color?
right here.
What color was the strontium?
Strontium was bright red.
Is that the strontium? We got it. See? Practical applications, people. All right, so I'm gonna turn this guy off again. I love it. We wanted the strontium where? At the very front, right? Very top, and then the lithium, and then the sodium. Now do we have it right?
What?
See, real life applications. All right,
Never gonna happen.
all right, now we're going to take some of this. This is our methanol. We're going to fill them up. Here's some. Okay, so I'm flooding each of our chemicals with methanol, a fairly decent amount.
Oh, methane.
Similar
Should put methane in.
structure, but methane's gas, so that won't work.
So put it in the air and see if it light the air.
Let me ask you this while I'm doing it. What's my countertop made of?
Adam, it's made of stuff.
Granite. Do rocks? Are rocks flammable?
Yes?
No, not at this temperature. Now,
No.
if you're gonna
Campfire, so it doesn't spread.
stick it, yeah, I was gonna say, if you're gonna stick it in the middle of the earth where it's super hot and there's a lot of pressure, yeah. But here, not flammable.
When it was snowing,
It's all good.
fire on the snow and it all turned blue.
It melted blue? All right, so I'm making sure they have a little extra. I want them to be like soupy.
The fire was blue.
That sounds beautiful.
Yeah, this was like, and
Wow,
they
so
did,
you're
like,
right in it.
we did like a circle of fire. Like a ring.
Cool.
It was so cool.
All right, almost there, guys. You're being very patient.
But then we just poured
What was the can again?
ice and snow over there.
This is methanol. All right, so here I have a wick that has been soaked in methanol. Soaked all morning. So what I'm gonna do is I'm very carefully going to make like a little loop, stick it in each one,
If something goes wrong, Zoom viewers will miss you.
Yeah, there you go.
Remember us
We
when
loved
we
you.
were.
Remember us. All right, so this is gonna be cool, but I'm gonna need y'all to stay in your seats.
We can't see.
Keep your goggles on.
Well, we can't see you back here.
Well, then you need to come up here, but stay behind those that are seated then. How about that? Let's not move the couch. Let's not and say we did. All right, so now I've got my little wick. Okay, get in there. That one wants to fight.
Oh God. Oh God.
Okay.
Oh God.
We're all gonna die.
Yeah,
Totally safe.
I practiced this. It's good. All right. Move stuff back out of the way.
Guys, this is so safe.
I have the extinguisher over there if we need it. Are we ready? Move these a little bit. Yes? Are we good?
Oh God.
Ready?
Wow. Yes, very amazing rainbow.
Woohoo! Give them a second. They'll get, once it gets through the wick and down into the chemical, like right here, it's still on the wick, right? Come on.
Yes, it looks amazing.
There we
It's
go.
like a mirror image. Why is it orange?
There it
I got some
goes.
blue and some red, got some green in the middle.
I got green sodium borate now. You see it? It wasn't green before, but it's definitely green right there.
Yeah,
You get down into here.
A
Get in
little like
there.
brownish green.
There we go.
Oh, I love the orange rainbow. It looks perfect.
Wait a minute. They're going. You gotta let them get down in there.
Where's the Johnny Cash music?
Yeah. Ring of fire.
Oh my gosh.
I can take this out because that one's already caught. There we go. Once they've
They're too
caught,
legit to quit. I'm seeing.
now we got it.
All of a sudden, just picking up fires.
Check that. See that? Here you go.
3 red things in a row.
3 red things in a row. Yep, kind of was. You see the blue now?
Oh, I almost saw a little yellow.
There's your green. See the sodium borate? It's actually going green here. That's pretty cool. Get the wick out of the way, and it's not going to burn the wick now. It's just going to burn the chemical, which is what we want. Because the wick is producing a color, right?
That's a yellow.
That's straight up methanol. There we go.
It's cool, but it's not really a rainbow.
It's getting there. Got to get these wicks out of the way. You see, because the wicks are making a color too, right?
There we go, now.
Now, what do you have?
Yes.
We have orange, red, blue.
I see the green in the middle. There's the sodium borate.
Orange, blue.
There's your potassium, right?
Perfectly green.
That's a purple.
It's a perfect
Cupric
rainbow.
sulfate needs to stir up a bit. Get in there. Ooh, the vacuum just came on. That's great.
The FBI's here. They're drilling in above.
No, that's my vacuum. What y'all think? Pretty?
No, it's beautiful.
Not impressed?
I like the red.
Yes, I am.
The red's my favorite.
I'm impressed. I think it's cool.
I understand why your teacher likes the red so much and why.
It's very pretty.
Red, blue.
Yeah, it's very, very pretty.
Amazing. All colors.
So how many of these things are toxic?
No, none of these are gonna be, in the state they're in, none of these are gonna hurt you to touch or whatever. Come on, do your thing. Get more blue. Very cool, right? So these will just, they will just burn out because they're not gonna, nothing's gonna happen to them to make them go out unless we smother them, right? This one's cool because the magnesium chloride is making like it's melted in there, it's dissolved, and that's pretty neat. And the lithium's pretty. The strontium. Copper's not being as cooperative as it usually is. Come on, there we go.
Start pulling your weight.
There it goes. Yeah, it's just being grumpy. I don't know what's up. And there's straight up methanol. Whoop, whoop, see? It'll burn out quickly because it's right there. And this is the calcium, and that's the sodium. Very cool. So, as those go out, or as those make their way to going out slowly, they'll just burn into, the cool thing about putting them in these tins is they'll burn until they're out of fuel, and then you can just add more fuel and burn it again. So that's kind of fun. So something I did for you guys just for fun and as a take home is candles. I made little tea light candles. And these tea light candles, I soaked them in some of these colors. Now look at that the boron. That's really green. That's great. Really pretty. So I have them labeled. I have them labeled so I can tell you what chemical they are. But you guys won't know until you light it. Maybe you'll get lucky and get a nice, you can really see it, looks cool. So pass these around and pick one. Okay, and then I'm going to give you guys all a chance to light them and see what you get. If you're at home and you got your candle in the mail,
We still have
you can go ahead and grab it.
We still have 25 more minutes.
Yeah, we're good. We'll probably end early on this one. So that's long.
Oh, we're ending early. That's good.
Okay, stay back there though. I'm going to let these do their thing.
Can't find the lighter.
And that one's out.
Trying to light a fire, you don't have it.
That one's done. On the other side. Pretty. Should have gotten
We just like lighting them.
not yet. I'm going to give you something to light them with. Here's the lithium. See? Pretty. I'm smothering them so we can get them out of here and we can use this space.
So smart.
You pick a candle? Okay, hold on a second. I'll let you light it. It's still hot. Out. They're going around. Did you find them? They're getting passed around. This one doesn't want to go.
I want to keep this candle.
Yeah, you get to keep it. It is your candle.
Yay! I want to run.
Well, maybe you'll get the color you want. Who knows? It's a surprise. Yes. Oh, they're getting passed around. They're somewhere. All right, so let me, hold on. I'm going to move all this back over. I'll tell you when to light it. All right, so here's what you're going to do. Y'all listening? Cole, Ethan, Michael, Alec, Jack, y'all listening? Okay, I'm going to give you guys each a long match. You're going to have to take turns coming up here. Okay, so let's do these three guys. Drew, can you step back and do these three guys first? All right. And you guys can probably share a match. I don't know how long it'll last. We'll see.
Oh, my dad got me those ones.
Yeah, these are nice because they're safety matches.
Yeah, I lit a little fire once.
All right.
I lit my first fire.
All righty. Let's see what Michael, Ethan, and Cole get.
No.
Maybe they're clear. Maybe not.
Any day now.
I really hope mine's red, like really badly.
I'll work on one of these while it goes.
Yeah, no. Yeah, let's get that.
Oh, really?
Oh, wow.
Go.
The ones in purple.
Oh, I think you need a new one.
Okay, that one's going slowly. Okay, let's
Sit
see.
down more.
This one's going. Do you need help with that, Michael? That doesn't want to go. Throw it in there. Don't wave it around. Throw it in there. There you go. I won't touch that aside. I'll get it with my forceps. Hang on. If it'll just go. I did not wax the wicks because I soaked them in chemicals, so that's why they're taking a bit longer to go. Yeah, try another one. That one didn't want to go. Okay, let's see Drew's. Do you have any colors over there yet, or are they just plain candles? Straight up candles so far, okay. Okay, how about you? Leave it right here, Drew. How about you, Jules? There's Jules. Hey, just put them down for me, Michael. All right, who's got one? Lily, oh, here, Ella. I don't know how well they'll work. We'll see. I know you can buy them pre-done, and they probably know what they're doing. Ella, Lily, and then Sky. Here comes Lily.
Oh, Lily,
Light the fire.
I think you got a green one.
Lily did get a green one. Come on in
I want
line.
either a green or like the bright red one.
Watch the candle wax.
What I
It's
do,
getting
I
this
just got
hot that it
normal
falls
one.
out like a blizzard that didn't.
Come on. It would just light.
Yeah. I've never seen
Here's
that happen.
Lily. Sky's been trying to hand me hers.
You look
Let's
Dairy
see.
Queen, they hand you a blizzard and they flip it and it actually falls out one.
Really?
Never had that happen, but I've looked. I see it.
Guys, remember where they are. Who's got one that
You get
needs it lit?
Sounds mine, Julie.
Yeah. Yeah. No, they
Sounds
don't.
It may not work, but we tried. Cool, guys.
Eat it.
Watch your hair, Lil. Lean back.
We'll give you a refund.
Abby's. Who else has one?
I want to
Alex.
light mine because I like.
Maybe it'll do something, maybe it won't.
Yeah, mine's not doing anything.
Yeah, they probably need a lot more chemical than I have on them, but I gave it a shot.
You're
Let's
getting really
put
close to
for
the
a
fire.
second. What do you think? That's kind of doing something.
Yeah.
Who else has one? Jack?
Can I light mine?
Yeah, you can try. Here, good luck. We got the box down there. Here. Who else has one that needs? Oh, your baby. You still got one, and Alec, you have one too. Yeah. Okay. Let's see. Bailey's. What's your
You're gonna light someone on fire.
Bailey's? And Alec, where are you?
I'll look at my hand through it.
Did it go? All right. Did everybody see the letter on the bottom of their candle?
I'm guessing we can't touch it.
I'll tell you what they are.
You can't.
You got A. Okay. I'll tell you what they are.
This was F.
I got B.
By the way, if it looks like an A, but it's curvy and not pointy, it's probably a D. Just so you know.
I got C.
Depending on how it's oriented.
Know where mine went.
Capital A's and capital D's. All right, there's Scott one. All right, so I'll tell you what they are. Those are right here. I only have 6 that I did. And they might work and they might not. Come on.
I think I.
So if you have an A, you have cupric sulfate. B was sodium chloride. C is lithium sulfate. F is potassium sulfate. G is strontium chloride, and D is calcium chloride. So you got any of those colors that might show up? Maybe not,
I have
maybe
E.
never. I don't know. We tried.
I
It off.
have E.
So do
You have E? Was E not here? Oh, what was E? It's probably still upstairs. I didn't bring it down. I'll have to go look and see what it was. I bet it's upstairs in the cabinet. It would have
I
been,
got D, and D did not work.
I think it would have been lithium barium.
Airbnb. Wow.
I think it would have been sodium
I
chloride.
think I gotta see. This is my guess.
Yeah, that one was yours, I think. All right.
Let's see.
That is lithium. So that should be pinkish red if it decides to play along. But I may
I
not.
did see some red.
All right. Which one was your favorite?
Green and
Strontium.
The copper and the strontium? Yep. Anybody else like the lithium?
represents you well.
The bright hot pink one? Hot pink red?
My favorite was the red one.
Ah.
The like bright red.
So there's one other thing you can do that I'll show you real quick. I'm gonna move all these this
Mine
way.
looks green, but that doesn't make sense.
There's one other thing that you can do with these. So which ones were the most colorful? The greens and the reds. So if we take our cupric sulfate, we put a, whoop, more than I wanted. It's not gonna hurt me to touch it though, so. We put a little here. Ta-da. Okay, and we took the, how about the lithium? Remember? This one was all crystally, right? So. There we go. A little of that down. Come on, be friendly. And then what? Strontium? Strontium, and then I think the sodium borate did really well once we got it out of the, put it here. Okay. Then, how about we put a little sodium borate down here? Now, if you do like so, okay, I'm just breaking it up a little. These are not gonna wanna do their thing. Okay. Y'all are back there, yes? Stay back there. They tend to do really well if you put them side by side.
Okay, you know like that?
Quick question. How would you ingest methane without
Eventually.
Or methanol.
There you go.
Wow,
So
that's
cool.
skilled.
Mhm.
It's a lot better like when I went to
I really want the red.
Isn't that pretty? That's the lithium. Strontium was down here. Cool.
Strontium was that way.
This one's the lithium because it's a crystal. So maybe
Oh, I
the
want the red and green.
strontium was, where'd it go? I don't know. But you can do like, there we go.
Oh, yeah. Oh, yeah. Like those, yeah, they make it like that.
Some strontium. Yeah, pretty. There we go. All right, so no write-up for this one. It's just to watch and see and experience. So we've got about 15 minutes before lab is technically over. So I'm gonna do some cleaning, but what I want y'all to do is put the chairs back where they go and blow out your candles gently and over the counter, please, not over the floor.
Yeah,
You can remove a mask, obviously, to blow. Drew, that doesn't work. Drew, come on. All right,
You can do it.
and then
Do it with your nose.
we will, careful. We will say goodbye to all our folks online.
If you're even there.
Bye.
Hey, and you
This one was
I want to appreciate it.
Oh, okay, okay.